Special products, a very significant topic where it is very useful, especially in factoring. So, why these products are called special? We are going to know why these products are called special as we go through this video. Let's start with the first special product, the product of a sum and difference of two binomials. With a definition of the product of the sum and difference of the same two terms is the difference of their squares, as represented below is its formula, where F stands for the first term and L stands for the last term. Let's try to evaluate the following expressions. Example number 1, we have quantity x plus 2 multiplied to quantity x minus 2. Remember that whenever you encounter a product of a sum and difference of two terms, just simply square the first term subtracted to the square of the last term. Then it is equal to x squared minus 4. Example number 2, we have quantity 2x raised to the power of 4y plus 6 multiplied to quantity 2x raised to the power of 4y minus 6. Again, just simply square the first term, where our first term is 2x raised to the power of 4y, and our last term is 6. And its answer is 4x raised to the power of 8 y squared minus 36. Just simply square the first term subtracted to the square of the last term. That is a very significant reminder for you. Don't you ever forget that. Let's proceed to the second type of a special product. We have the square of a binomial. With the definition, square of the first term and add twice the product of the two terms, then add the square of the last term, as represented below. It is the formula. Given a square of a binomial whose sign is positive and the other one is a square of a binomial whose sign is negative. You don't need to memorize this formula. Just simply familiarize these following formulas. Let's try to evaluate the following expressions of a square of a binomial. Example number 1, we have quantity x plus 4 raised to the power of 2, or quantity squared. It is just simply equal to x squared plus 8x plus 16. Why? Because we square the first term, which is x. Now we have x squared plus twice the product of the two terms, which is 4 and x. So we have 8x. And lastly, plus the square of the last term, which is 4. That is why we have positive 16. Let's have our second example. Quantity x squared y cubed minus 2b squared quantity squared. Again, it's a formula, or substitute the formula if you want. If you can't familiarize the formula, you can also memorize it, because we are not pushing you to familiarize it. It depends upon you what's your style of remembering the formula or familiarizing it. Now let's proceed to its answer. X squared y cubed square is equal to x raised to the power of 4, y raised to the power of 6. Apply the power law of the exponent. law given, where given a power or an exponent, just simply multiply those exponents. Now we have x raised to the power of 4, y raised to the power of 6, minus 4x squared, y cubed, b squared, plus 4b raised to the power of 4. If you are wondering why it is negative 4x squared, y cubed, b squared, it is all because this kind of binomial has a negative sign on its last term. So we have a negative sign on the second term of the product. And if you're wondering why it is positive on the last term, since it is squared, negative squared, given a negative number, if you're going to square it, its answer will always be positive. Note, whenever you encounter an exponent raised to another exponent, just multiply the exponent, as I've said a while ago. Now let's proceed to our third special product. We have the square of a trinomial, with the definition of square each terms first plus twice the product of the terms taken two at a time, but the product will depend on its given. As you can see, we have 4 formulas in the square of a trinomial. Why? Because we can also encounter a negative last term, negative middle term, or both negative middle term and the last term. When the last term is negative and the middle term is positive, the negative signs on the product is located on the 5th term and the 6th term. And that's the clue I am giving you. The same goes with a negative middle term and a positive last term. The negative signs are located on the 4th term and the 5th term of the product. The same goes with the last formula. Whenever the middle term and the last term are negatives, the negative signs in the product are located in the 4th term and in the 6th term. Let's try to answer or evaluate the following expressions. Example number 1, we have quantity x plus 3y plus 2z, quantity squared. Applying the first formula of the square of a trinomial, we are going to derive with an answer x squared plus 9y squared plus 4z squared plus 6y plus 12yz plus 4xz. As you can see, we have 6 terms in the product. Why? Since it is a trinomial, quantity squared, then we are operating all the 3 terms in the trinomials. X squared, now we have x squared, and plus the square of the middle term, which is 3y, we have 9y squared, plus the square of the last term, which is 2z, we are going to get 4z squared, plus twice the product of the first term and the middle term, we get 6xy, plus twice the product of the middle term and the last term, we will derive with an answer 12yz. And lastly, plus the product plus twice the product of the first term and the last term, we will get 4xz. Let's proceed to our second example. Quantity x plus y minus 3, quantity squared. Again, the formula on the square of a trinomial is simply in the first step, square all the terms, starting with the first term, followed by the middle term, and the last term. As you can see, the last term is negative. What I am reminding you, whenever you encounter a negative sign on the last term, then we alter its formula. Now we have the answer. X squared plus y squared plus 9 plus 2xy minus 6y minus 6x. Starting with x squared, why is it x squared? Because we squared the first term, which is x, added to the square of the second term or the middle term, which is y, we get y squared, plus the square of the last term, which is 3, we get 9. If you're wondering why it is positive 9, negative 3 raised to the power of 2, or negative 3 squared, is just equal to positive 9. Plus 2xz, which is twice the product of the first term and the middle term, minus 2, or twice the product of the middle term and the last term, minus twice the product of the first term and the last term. So we get our final answer, x squared plus y squared plus 9 plus 2xy minus 6y minus x. Proceeding to our third example, we have quantity 2m minus 3n plus 4 quantity squared. As you can see its answer, we have negative signs on the fourth term and the fifth term of the product. Since our middle term in the trinomial is negative, that is why in the product, we have negative signs in the fourth term and in the fifth term. So, it is the same process with example number 1 and number 2, but we alter it with its negative sign. That is why we'll depend our formula on the given. Proceeding to our fourth example, we have quantity 3x squared minus 2y squared minus 1 quantity squared. It is just simply equal to square of the first term, which is 3x squared, we get 9x raised to the power of 4, plus the square of the middle term, which is 2y squared, we get 4y raised to the power of 4, plus the square of the last term, which is 1, we get 1, minus twice the product of the first term and the middle term, we derive with an answer 12x squared y squared. If you are wondering why, it goes with this process. 2 multiplied to 3x squared, we get 6x squared. Multiplied to 2y squared, that's why we have 12x squared y squared, plus twice the product of the middle term and the last term, we have 4y squared. And lastly, minus twice the product of the first term and the last term, we get an answer of 6x squared. Thus, the final answer of this expression is 9x raised to the power of 4 plus 4y raised to the power of 4 plus 1 minus 12x squared y squared plus 4y squared minus 6x squared. Proceeding to our last type of special, we have the cube of a binomial. This is the last type of a special product, yet this is the most crucial one. If you want to know why, let's know why. As you can see, it has a definition of the cube of each term plus thrice the square of the first term multiplied to its last term plus thrice the product of the first term multiplied to its square of the last term plus the cube of the last term, as represented in the formula below. Quantity f plus l raised to the power of 3 or cube, we get the cube of the first term plus thrice the product of the square of the first term and the last term plus thrice the product of the first term and the square of the last term plus the cube of the last term. As you see it, as we can see, we have two following formulas. Why? Because there are also binomial whose sign is negative. Just like below, we have quantity f minus l, quantity cube. And as a clue, whenever you encounter a negative cube of binomial, the negative signs in the product is located on the second term and on the last term or the fourth term. Now let's proceed to our illustrative example. Let's try to evaluate this expression. We have quantity 2a plus 3 quantity cube. We derive with an answer 8a cubed plus 36a squared plus 54a plus 27. Applying our formula 1 in the cube of a binomial, if you want to go back, you can go back our video to check whether it's correct or not. So the cube of the first term, which is 2a, is 8a cubed plus thrice the product of the square of the first term and the last term, we get 36a squared. If you are wondering why, we multiply 3 to the square of the first term, which is 2a, and multiply it to our last term, which is 3, and we derive with 36a squared. Just the same with the 54a. It is thrice the product of the first term, but the square of the last term. And lastly, the cube of the last term, we get 27. Proceeding to our second example, quantity 3x minus 5y quantity cube. Again, since the negative sign is on the last term, or the binomial, the cube of a binomial has a negative sign, we follow the formula on the second formula of the cube of a binomial, where the negative signs are located on the second term and on the fourth term. As you observe below, negative 135 x squared y, and we have negative 125 y cubed. If you are wondering why we have bigger numbers, let's try to situate it one by one. Start with the cube of the first term, which is 3x. That is why we have 27x cubed minus thrice the product of the square of the first term, which is 3x, and the last term, which is 5y. 3x squared multiplied to 5 and multiplied to 3, we get an answer 135x squared y plus thrice the product, or 3 times 3x times 5y squared. We get an answer of 225x y squared. And lastly, cube of the last term, which is 5y, we have 125y cubed. Thus, our final answer is 27x cubed minus 135x squared y plus 225xy squared minus 125y cubed is just simply equal to the quantity of 3x minus 5y cubed. That would be all for our discussion. For more exercise to answer, please visit www.facebook.com/teacherfranz/ I will just post there the exercises, the following exercises, which is labeled as easy, average, and difficult. Thank you for listening and watching my video. And please don't forget to subscribe.